Student, we have to discuss this system solved by Gauss Jordan methods. First, we this system is reduced by matrix representation that is mean by ax equal to b. This is x1 x2 x3 is three variable, and minus 1 b minus 1 4 c is b is constant. Then a is this linear equation. We have to get this a. That means x1 is a variable, this coefficient is 1, x2 is variable, coefficient is 2, x3 is variable, its coefficient is 3, x1 is variable, coefficient is 1, x2 is variable, coefficient is 3, x3 is variable, coefficient is 1, x1 is variable, coefficient is 1, x2 is variable, coefficient is 3, x3 is variable, coefficient is 2. Then x1 x2 x3 is these three variable, minus 1 4 3. Then ax equal to b. We have to this system of equation find in Gauss Jordan method. That is mean by now with this matrix A is reduced by row echelon form. This row echelon form we now we convert matrix A to reduce the row echelon form. Means this matrix A is reduced by 1 0 0 0 1 0 0 0 1. This matrix A is reduced by this equation is called a row echelon form. That is mean by first is already in this matrix A, but this second row it is 0 but is not in 0. Then we have to apply row operation. That is mean by r2 it changes to r2 minus r1, and this is r2 is changed, then also in r3 change, because first is leading element 1, the second row is 0, and third row is 0. Then mean by this 1 is replaced by r2 changes to r1. Then similarly r3 changes to r3 minus r1. Then we get this is matrix A. This one r1 is not changed, then this matrix A. Similarly, and matrix this is this r2 changes to r1, that is 1 minus 1 0, 3 minus 2 is 1, 1 minus is 2 is minus 1. Then r3 changes to r3 minus r1, 1 minus 1 is 0 0, 3 minus 2 it is 3 minus 2 is 1, and 2 minus 2 is 0. Then x1 x2 x3 is 3 variable. Similarly, this matrix is changed, then this matrix is also changed. Minus 1 it is r1 is not changes, but 4 and 3 is also changes. This is r2 changes to r2 minus 1, that is 4 minus 1, that it means by 5. Then 3 changes to this r3 changes to r3 minus r1, 3 minus 1, that is mean by 4. Then is 1, and this 2 now changes to this 0. That is mean by r3 is changes to r3 minus r2. Then we get then we get this 0. Then we get this 0. Then mean by 1 2 2 is not changing first row, 0 1 minus 1. Second row is not changed, but third row is changed. x1 x2 x3. Similarly, this minus 1 5, right? Only third is changed in minus 1. This first row is not changed, second row is not changed, only is third row is changed. Then this one, this one, this one. Now this 2 is also 1, this 2 is also this 2 is reduced to 0, this 2 is reduced to 0. That is mean by r1 changes to r1 minus 2 r2. Then we get 1 0 4. This is r1 changes to that. Similarly r2 is not changed. Then similar the above matrix A. Then x1, x2, x3. r1 changes to 2, r2 means minus 1 minus 2 into 5. That is, this is the minus 11. Minus 11, 5 minus 1. Then this also 0. This is also reduces to 0. That is mean by r1 changes to r1 minus 4 r3. Then we get 1 0. 4 r3 is 0. Then r2 is not changed and r3 is also not changed. Then x1, x1, x2, x3 equal to r1 is change is minus 7 is 5 and minus 1. It is r2 and r3 is not changes. This is minus 1 is reduces to 0. That is the r2 changes to r2 plus r3. Then we get 1 0 0. r1 is not changes but r2 is changes 0 1 0 and 0 0 1. r3 is also not changed. This r2 changes to r2 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 plus r3, r2 plus r3. Then and x1 x1 x2 x3 minus 7 4 minus 1 only changes to r2. This 5 plus 3, 5 plus 3. Then we get the solution of x1 equal to minus 7, x2 equal to 4 and x3 equal to minus 1. This is the system of linear equation. These three system of linear equation, by using Gauss-Jordan method, we get x1 equal to minus 7, x2 equal to 4 and x3 equal to 1. Thank you.